Welcome to the lecture. In this session, the lecture based on the op-amp design, how to design an op-amp amplifier. Uh, like this, you hear in the like inverter, non-inverter. This is given to the circuit. This Y, then it give the feedback. Again, you get to hear for amplifying. Suppose we just call as beta. This is a feedback. Then the given input will be given to the feedback for the amplifier to check the uh, to performance of the amplifier, so that before we just learn some basic things like common source, gate, drain configuration. Now we start with the source. So by drawing the MOSFET, like this is gate denoted as G. This is drain, and this is source. And before that, we add here the V bias, like because this MOSFET will perform in the saturation region. So you may know that the saturation region is active region, saturation region, and this is cutoff region. So in MOSFET, like this, so that we measure the V out here. This is V out. We are finding V out. This is V in, because we given the input in the gate terminal, the V input. So in this case, V input is equal to infinity, whereas in the V out we find that, so V out is equal to, you guess that V out is equal to, what is the V out? This is simple. In the V out is equal to, in the small signal analysis, we learned some basics in like GM, VGS, then RD, GM times VGS, RD parallel or not in V input. So this is a condition. This is a V out for this common source configuration. For the given input, we get the V out like this. So before that, I just teach something like this. In like see that in the circuit, like see here we have to measure the VO. So the current will from the VGS here to here. This is source. So in this side we you see the small signal analysis, like the current source, and the here is a RD. This resistor grounded. This is R naught, and here the resistor RT. So in this VGS, the current, the it will flows like this here and here. So it will when the this is VM, like, GM VGS, and this is R naught. So the current will flow like this after the here. So from this it will like in this direction. So we put like the current enter like this. So if it positive in the forward direction, we just mention here minus. So but here in the down, because the current will enter like this. So you put the plus here. After that, you enter to the RD, so that the like GM VGS time into RD value or not we input. This is one case. Whereas is and then another case like that is same like MOSFET. We turn gate grounded G. So here we just mention here drain, and this here is source plus minus VGS. We as the gate to source. We are currently seeing the common source configuration, so that we measure like this. We have so now we note that like before in the here current source, suppose like that. Uh, if smart signal current source is present here, then we just v input, like v input is equal to infinity. Now we find the v out. What is v out? Anybody guess like that? V out is equal to what? Guess. See that just simple like here, like grounded this RD. You just see that. So if this is if current we just here current it flow like this after to reach RD, so that in this case we input is infinite. So whereas V out is equal to what by this, like see this is smart signal analysis scale analysis. So this is current, so that if current flows like this direction, so but we are using buffer like this. So which what is do like this here, we get v out is equal to v in. Same like if v out is equal to 1 volt, then here also we get 1 volt, because here it will current source. So if when current flows like this, it will maintain the constant variable current. So that we just mention that if you get v input is equal to 1, then v out is equal to same. What is the present view mean? That's all. So for understanding, just I mentioned like that, for simple understanding, just this condition. See, uh, for smalls like this, see, mm, see this is like see this IQ. This is this I will draw in, see for here I just mentioned that, see, like see this is RD, and this is terminal current source. When this is when we input, if RD is present like this is RD. See, this is RD. If I want to carry this current to here, this RD, so what I do is it will ask some current loss will occur, so that I want to if here is 5 volt, but after this reach the RD by 5 volt, it's not possible, some current will losses. So what I'm doing is just I put the see like this, uh, just I'm copying this voltage, like this is R S, or this is source. So if what I'm doing is like that, I'm just copying this here, like I use this. After that, what I'm doing, I just copying this voltage, like I just copying this data to here. Just copy. See then it reaches this. So see that if I am copying this by this is a buffer, so I will get the RD by 5 volt. I will achieve this because what are the given to here gate terminal the input, it will get achieved like this. So by this and here there's a comparator compare like this. So we get the R naught here. This is RD. This is RD. Like small output in this we can get like this. So that I'm telling like this. So this is uh, uh, GM VGS the condition just for small signal analysis. So that this time it's not enough. Just understanding this I'm confusing like this. Like this is a simple concept. A common source configuration